Good day. In this video, I'm going to discuss about the case of two related samples, specifically the McNemar test for the significance of changes. The content of this video are the following. First, I'm going to define the test. Second, I'm going to enumerate the assumptions of this test, the McNemar test. Third, I'll be giving an example. And fourth, I'll be using a digital technology from that example. The term McNemar was named after Queen McNemar. He was a professor in the Psychology and Statistics Department at Stanford University, and he was the one who created this test, the McNemar test. This test is a non-parametric test which assesses if there is a statistically significant change in proportions on a dichotomous dependent variable between two related groups. Let us say, for example, we're going to determine whether the proportion of participants who had low self-esteem before a series of counseling sessions decreased after the intervention. The counseling session is the intervention or the treatment, and the dichotomous dependent variable will be the level of self-esteem, which has two related groups. We have the low and high. This test is represented using a 2x2 contingency table, or we have 4 cells all in all. I have mentioned about dependent variable having two related samples. Now the question is, when can we say that samples are related? First, they are the same people in both samples. This is usually called repeated measures or kanang mga pre-test and post-test, or before and after treatment, which means that the same participants will give us data on two measures. We have the before and after. Another one is individuals in the two samples are essentially the same person, which means that it is really not necessary that we have the same participants from before and after, because we can match our samples based on certain characteristics. Let's say, for example, we're going to match the samples according to their age, to their sex, etc. And it is also often called a match pairs design. There are three main assumptions for the McNemar test. First, we have you must have one nominal variable with two categories, for example, dichotomous variables, and one independent variable with two related groups. From my example ganiha, sa one nominal variable with two categories is the self-esteem, and then the two categories is either low or high. And then for the independent variable, this refers to the samples that we use. We have the pre-test, post-test, or the match pairs design. The second assumption states that the two groups in your dependent variable must be mutually exclusive. In other words, our participants cannot appear in more than one group, because when we use the McNemar test, we cannot record the participant as having low self-esteem and at the same time having high self-esteem. Lastly, the sample must be a random sample, which means that in a population there must be unequal chances for the participants to be chosen. As I have mentioned a while ago, in order to run a McNemar test, our data should be placed into a 2x2 contingency table. So this is what the table looks like. We have 2 columns and 2 rows. That's why it's called 2x2 contingency table. And ari lang ta mag-focus sa kanang A, B, C, D, because later on there will be frequency diha or numbers. Sa cell A, there were no changes sa responses sa tuang respondents, kay iyang answer sa first condition is yes, and then pag second condition is still yes. Sa cell B, we can see there is a changes sa responses. We have from yes and then no. Same with cell C, there are still changes from negative or to positive, or no to yes. And for cell D, there were no changes because for both conditions is negative iyahang response. And we have n as our number of samples. When we say discordant pairs, it comes from match pairs of results in which two categories are different. From the table ganiha, we have the frequencies B and C, which means that there is a disagreement sa iyahang response. either ni-shift siya or there were changes. Let's say for example, pag first condition is nag-yes and then nag-no, or from no to yes. As opposed, concordant pairs come from matched pairs of results in which two categories are the same. In other words, there were no changes sa iyang responses or there is an agreement. By the way, the McNemar test is a special type of chi-squared test. That's why sa formula we are using the chi-squared test. So this is the hypothesis, but later on I will just give an example with its more detailed na nga hypothesis also. To put simply, the McNemar test can be used if we're going to check if the intervention or the treatment is successful, and this test is mostly used siya sa mga researches or mga studies sa mga medical nga fields. Now let us consider the data below on seatbelt use before and after involvement in auto accidents, for example of 100 accident victims. The question is there a significant difference in the use of seatbelt before and after involvement in an automobile accident? The intervention for this example is the automobile accidents. What we are interested to determine is that if there is a difference ba daw sa pag regular wearing of helmet before sila na accident and after. Since we are testing the regular wearing of helmets before and after the accident, so for our hypothesis, for the null hypothesis, we have people do not use seatbelts more regularly after an automobile accident, while for the alternative hypothesis, we have people use seatbelts more regularly after an automobile accident, and that is our claim, the alternative hypothesis. The following are the digital technologies that could run the McNemar test, and for this example, let's try using the Excel. So this is how the data is placed sa Excel, and we have 100 respondents man, so maunang giusa-usa na to sila og placed every cell. And magwonder mo kanang 1 diha, it means yes, and ang 0 is no or negative. That is based from the responses of the respondents. We have the response nila sa pre-test and sa post-test. Karon is kwaon na to ang discordant pairs or ang disagreement sa ilang responses. We have the pre-test minus the post-test. So ang formula ni sa Excel is equals and then B2 minus C2. To identify the discordant pairs, 0 ang mugawas like this one, concordant na siya. But if dili gani 0, let's say for example 1 or negative 1, kana nga pairs are negative or discordant pairs na sila, which means nga there is a disagreement. Dali ra, i-click na to ang kanang first na to nga sample and then i-drag to the end and then autofill na lang largo. From the pre-test minus post-test na to nga column, let us count how many ang respond from yes to no. Sa formula for this one, we're going to use positive 1 because ang yes na to since 1 and then ang no is 0. Yeah, we're looking for the responses from yes to no man, so 1 minus 0 is 1. The result nga atong makuha will be our value for B. And we got 6. Same also with the responses from no to yes, we're going to count them, and this time we're going to use the negative 1 because 0 minus 1 is negative 1. ang value nga to makuha will be our value for the C, and we got 19. Now we're going to apply the formula for the McNemar test, which is the absolute value of b minus c minus 1 squared all over b plus c. And the result is 5.76. For the alpha, we're going to use the 0.05 significance level. To get the critical value, we have chi inverse, then in-close sa parentheses ang value sa alpha, and then 1 as our degrees of freedom. So we get 3.841 for the critical value. This is the distribution table for the McNemar test, which is similar sa sa chi-square test nga table. Let us now proceed to our third step, which is the decision rule. Since our chi-squared computed is greater than the critical value, then we're going to accept the alternative hypothesis. For the conclusion, we are going to reject the null hypothesis, which means we're going to accept the alternative hypothesis. Therefore, people use seatbelts more regularly after involving in an automobile accident. And that's a wrap.